Welcome to the 11th video in this series, which we've called Life Cycle Analysis and Beyond. So far in this series, we've been talking about human activities and the natural world as identifiable layers of our metaphorical onion. But if we're going to improve our overall relationship with this planet through the variety of ways we live on it, we have to find some useful metrics, ways to measure if what we are doing is good, better or worse than something else. After all, on an environmentally respectful planet, no one is expecting to stop people from enjoying their lives. There's every likelihood that a healthy planet would look quite similar to the way we live today, at first glance. We'd all likely go to work, entertain and educate ourselves, cook, travel, play, and hopefully with respect for one another. But up to now, our measures of success and progress have been through our creative adaptation of the resources available to us on the planet, a planet that for a long time was considered to be almost infinite in its supply of riches, there to explore and exploit. As we mentioned previously, our measure of economic success, our GNP or GDP, is a measure of activity and not with due regard for environmental responsibility. But that's changing. Now, before we try to develop some means for solutions or improvements, we have to consider an important term: value. In reality, there is no such thing as absolute value. Things have value because we think they have value, and for no other reason. And that value changes from person to person and over time. Consider today's newspaper, about $1. But what would it be worth, say, in a week's time? Not very much. Then what about in 1,000 years' time? Same product, different circumstances. In contrast, we can ask what value is a non-renewable resource that nature contrived to create in the land around us? Or what is the value of our fresh water? Many argue we have only just realized that we have grossly undervalued these resources over the years. They are vital to maintain and largely irreplaceable. So let's start by making a bit of a leap to the work of Abraham Maslow. We mentioned Maslow's work in a previous video, and hopefully it'll be useful in starting our exploration into how we can measure and value our environmental impacts. Abraham Maslow was an American psychologist who was best known for creating Maslow's hierarchy of needs for our psychological health, which culminated in the need for self-actualization. At its base level, Maslow's hierarchy starts with the fundamental needs such as breathing, food, sleep and water. At the next level we find security of body, employment, resources and the family. Next we come to the need for friendship and the creation of family. He then moves to self-esteem and confidence and respect of others. His highest level is related to self-actualization, morality, creativity and spontaneity. This hierarchy has proved to be a very significant tool. So we're going to take it and see how it can be applied to our human needs and activities, especially with regard to our environmental impacts. So let's start at our base level with the fundamental need for us to survive: food, water, fresh air, survival. That's reasonably obvious. The next level relates to safety, that we won't be attacked or suffer a major health concern. Next, we want things to be convenient. Food supplies, fresh air and water, close by, near our homes and places of work. Not surprisingly, we would like this also to become comfortable, without drudgery and hardship. So comfort's the next level. Beyond that, it gets to be interesting. Luxury. And the very next level starts to explain why. That level we will call decadence, and it brings with it the notion of decay, going too far. Beyond this we go to dangerous, as a reflection of undesirable human activities. And finally to disastrous, a place that none of us wants to go to. So let's go back to luxury for a minute. Here the words of Jamie Oliver, the British chef, help us. He describes chips or French fries as a luxury. They're very nice, but not something we should eat every day. A luxury is actually a treat, something to have occasionally. So to add to that list, I'd suggest champagne. Every now and again, it's good to celebrate an event with champagne. And the last edition, the Olympics. Hopefully not environmentally wasteful. And not every year, but every 4 years, it seems to be a good idea for the athletes of the world to come together and compete and demonstrate their athleticism. So, with that hierarchy in mind, it may help consider the real value of our activities and how close we are to our goal of doing healthy things in healthy ways. And now for the main theme of this video, the challenge of life cycle analysis. Life cycle analysis, or sometimes assessment, LCA, is a relatively new concept, about 50 years old, which tries to address the complete costs and impacts of a product or an activity throughout its whole life. And to explain, I'm going to use a graph. On the horizontal axis, we start with time, which for convenience we won't break up into exact units. The vertical axis is value, which, with regard to our previous hierarchies, we will say is based largely on utility, usefulness, rather than on sentimentality, for example. For now, the origin of the graph will be the planet Earth that mankind was fortunate to find itself on, with all its wonderful natural resources ready to explore and exploit. So now let's start to make something. We'll begin with a resource and make it into a valuable material. Let's say we take bauxite and that we turn it into aluminum. Many of our resources are transformed in a similar way, from ores to minerals, into valuable and then useful materials. Next, we take this raw material, aluminum, and turn it into something useful. In this case, anything from a pop can to an aircraft. But really, it is any product that we would find on the market, at which point it is sold to a user or consumer, and for many reasons, it deteriorates in value as it is used. We all understand this concept, like with a new car, for example. This deterioration in value could take years or days, and there would likely be some maintenance or upgrade along the way. Now, the area under the graph signifies value and cost. In manufacture and in the consumer use stage of this graph, there'll be waste created and energy used. And this is part of the graph. But in principle, if the area under the manufacture section, let's call it A, is less than the area under the use section, let's call it B, then society will generally think that this has been a worthwhile activity. Well, that's how we used to think before we started to consider the waste and what happens at the end of the product's life. You'll notice that we've drawn a horizontal line from the raw material point. We'll explain that later. But now, at the end of the product's life, some obsolete products become antiques or collectible and achieve values far higher than the original item. But these are relatively few and far between. The majority of products become waste. This could be neutral waste, where they have little environmental impact except to take up space, like a piece of glass or a stone. Other materials can be toxic and have impacts on habitat, water systems, and even human health. You can probably imagine what a nuclear weapon would look like on this graph. On a positive side, some of the products can be recycled, though usually not to make a product of equal quality, like the paper products we mentioned earlier. And the cycle would continue. Now, most products are made up of several different materials. You may remember that today's laptops often contain up to 35 different materials. So the lines on the graph here would be multiple, dependent on the materials. And the impacts could be great. So for life cycle analysis, we must add in this waste phase. So now the area related to waste or disposal, let's call it C, must be added to the area of manufacture, A, and this must now be greater than the area of use, B. And you can see that we now may have some problems. Was it really such a good product? There's also an important message related to the line we added for refined manufactured materials, like aluminum. Clearly, we want to retain that refined material value into new products and not let it randomly find itself in the waste stream. It's much harder to recover precious materials from there, and clearly any negative impacts would need to be dealt with. Very conveniently, these three parts of the graph, A, B and C, form the vital components of life cycle analysis: manufacture, use and discard. Manufacturers can use this type of information to improve their costs and environmental impacts, as such demands become the law. Similarly, the waste management industries can deal with their part of the graph. But is it fair for them to pay for the potential impacts of long-term environmental damage? The answer is no. The consequences of waste through many of our manufacturing and industrial processes are quite predictable. So the impacts of discard and waste must be made accountable before any decisions are made to produce something in the first place. And this isn't easy, but laws and standards such as ISO 14000 for environmental activity exist and are being developed on an ongoing basis. But life cycle analysis is seen by many today as an expensive process. But a large body of analysts are developing data that helps us attribute real values and costs for all our activities. And that origin that we chose for the start of the graph, it really should have a much higher value. We really have taken the richness we inherited too much for granted. One interesting realization to add is that with so much developing effort going into data, it's now possible to undertake preliminary life cycle analysis studies in which only 20% of the effort can lead to 80% of the solution. It helps to identify hotspots, problem areas that need immediate attention. And there's one final important point to be made. The use phase that appears to be the driving force behind all these industrial activities in the first place is down to us. It reflects our hierarchy of needs and activities, our necessities, comforts, luxuries, and beyond. We can treat the products we buy very well if we want to, and not use them too much, and not waste energy, and be careful how we dispose of them. But the question will remain, why do we need so many of them in the first place? Remember, sustainable living is really all about doing healthy things in healthy ways. We'll see you next time when we'll be asking why nature has no labels. We'll see you then.